Have you ever wondered why, with all our advances in artificial intelligence, we don't have AI doctors in every hospital? One of the biggest hurdles is a problem of translation. An AI model trained to detect seizures from brainwave data in one hospital might become completely unreliable when used in another. The subtle differences in equipment, patient populations, and even room temperature can create a domain shift that confuses the model. It learns the quirks of its home environment, not the universal truths of the medical condition. This paper offers a clever new way to solve that problem. The researchers behind this work realized that current AI models often have tunnel vision, looking at complex medical data from only one angle. Their solution is a framework inspired by how a human expert works, by considering multiple viewpoints to form a complete picture. They call their method multi-view contrastive learning. Instead of just feeding a raw medical signal, like an electrocardiogram, ECG, into the AI, they teach it to see the data in three different ways simultaneously. The first view is the temporal pattern, the familiar squiggly line over time. The second is the derivative-based view, which looks at how fast the signal is changing, capturing its dynamics and momentum. The third is the frequency view, which uses techniques like a Fourier transform to break the signal down into its constituent frequencies, much like a prism splits light into a rainbow. The magic happens next. The system uses a machine learning technique called contrastive learning to force the model to find the common ground between these three views. It learns to recognize that a healthy heartbeat signal, regardless of whether it came from hospital A or hospital B, shares an essential, underlying signature across all three perspectives. By doing this, the AI learns to create a feature-invariant representation, a core understanding of the signal that is robust to the noise and variations of different environments. The researchers tested their framework on a variety of challenging medical time series datasets, including brainwaves, EEG, heart signals, ECG, and muscle activity, EMG. Their multi-view approach significantly outperformed other state-of-the-art methods designed to solve the same domain adaptation problem. This shows that teaching an AI to look deeper and from more angles is key to its success. Of course, this approach isn't a silver bullet. It's more computationally intensive than simpler models, and figuring out the optimal views for every possible type of medical data is a challenge for future work. Still, this research marks a critical step forward. It moves us away from brittle AI that only works in a lab and towards robust, generalizable systems that can be deployed with confidence in the messy, diverse reality of healthcare. It begs the question: if we can make AI more reliable by teaching it to see from multiple perspectives, what other complex challenges could we solve with this approach? If you enjoyed this breakdown, don't forget to like, comment, and subscribe for more AI research made simple.